Hello students, my name is Emma Reed. I am an 8th grade math teacher, and today we are continuing Unit 8, the Pythagorean Theorem and Irrational Numbers. Our topic for today is edge lengths and volumes, and our big focus question is how can we approximate cube roots? So throughout the lesson, I want us to think back to this question of how is what we're doing related to edge lengths and volume? And what do edge lengths and volume have to do with cube roots? So let's go ahead to our introduction/launch on slide A. And on slide A, we're answering the question if one face of a cube has a surface area of 36 square inches, then what is the volume of the cube? And explain your reasoning. So you are free to try this question on your own if you feel ready to start. If it helps you to visualize in order to answer the question, I'm going to offer you another site that you can try out to see if it helps you answer this question. So here we are back on GeoGebra. We've used this website before, and I'll put the link to the website at the top of the screen. And on this website you can see I have a 4 by 4 by 4 cube. So the edge length is 4, and we can ask ourselves what would the volume be. So you can adjust the length, width, and height to suit the problem that you're answering. You can also change how opaque or transparent the cube is. So if you just want to focus on the 3D version, or if you want to imagine that you can see through it and think about each of the faces, like we're being asked about in our introduction/launch, you can also create a net by opening up the cube and putting it back. So you can use this to support you for the introduction. So go back to that question, consider it, and take some time to answer that intro. So pause, do your think time for the intro launch section, and then we'll go back to that applet a little bit and then move on to our explore section. Now that you've had some time to think through this question, let's go back to our app here. And we are going to think about what is the connection between an edge, the surface area of a face, and the volume. And I'll use my cube with an edge length of 4 as an example. So if we have this edge length of 4, and we know it's a cube, then I can say, all right, my edge length would be 4 inches. That's my edge. And then if I were going to find the surface area of, let's say, this yellow face, that would be my 4 inches by, or times 4 inches. And that would be 16 square inches. And then if I wanted to find the volume, I would be doing my edge length times my edge length times my edge length, which would give me, still inches, which would give me 64 cubic inches. Right? So we have a relationship here where we have the edge length, and then we have the edge length squared for the face of a cube. And then we have the edge length cubed for the volume of the cube. And then we can think about it as we move through this lesson. All right, what can the edge length, the surface area of the cube, and the volume of the cube do for us when we're trying to visualize square roots and cubed roots? So now we're going to move into our explore section on slide B. And on this slide, our task is to add the letters to the number line in the location that corresponds to their value. So on this slide, you're thinking about the square root of 50, the square root of 18, and the square root of 5.5. So take some time here, pause and think, and decide where to plot A, B, and C on this number line. When you've got your answers, just take a moment and think back to this visualization of a cube, right? What are we doing in relation to the cube when we take the square root of 18, let's say? What is the 18 and the cube? Which measurement? Is it the edge? Is it the surface area of a face? Or is it the volume? And what is our answer when we take that square root? Which of those three? And we're going to bring that thinking with us also into slide C of our Explore section. And now we have new letters. We have D, E, and F. And our goal is still to add to the number line for the location that corresponds to each of their values. So now we're looking at the square root of 90, the cube root of 22, and the cube root of 100. And again, as you think about this slide, think about, well, what is the 100, the 22, and the 90? What could they be? And what would their values be in relation to the cube? So what would we be figuring out when we take the square root of 90 versus the cube root of 22 or 100? So pause and think about this slide. And when you're ready, we'll move on to the next section of our Explore section, slide D. And on slide D, we have a very similar task. We have 3 new letters, G, H, and I. And our goal is to add the letters to the number line in the location that corresponds to their value. And this time we have the cube root of 957, the number 8, and the cube root of 50. So pause, take your time to do this task and think it through. And when you're ready, we'll move ahead to the last slide of our Explore section, slide C. On slide C, we have 2 reflection questions to process what we've been working on. And on the left-hand side, we're answering the question, how did you determine where to place each of the letters on the number line? And on the right, you'll be answering the question, which of these numbers did you place further to the right? The square root of 18 or the cube root of 100? How do you know? So take your time to think about both of those questions and answer in the blue square. And when you're ready, we'll move to our final slide, our summary section. And to summarize our learning and make sure we remember for the future, we'll be answering our focus question on the left. How can we approximate cube roots? And on the right, use the space to record any notes from the lesson summary that you want to keep in mind for the future. Thank you so much for joining me, and have a wonderful rest of your day.